a PhD student down the street at the Status Center at MIT. My PhD is in data visualization, and I'm really excited to share the work that we've been doing over the past few years. Today I want to talk to you about two things. The first is about how to design effective graphics for bespoke data sets, and the second is to show you a tool for building those graphics. So how do we decide what chart to use today? So maybe you're lucky you have some existing collection of charts you know works well for things you've seen before. Maybe today you might be able to get away with vibe coding a chart that looks pretty good. But when we're faced with a new problem, what should we do, right? So one thing we might do is sift through these very large example galleries or books of a bunch of examples and trying to figure out which of those might apply to our problem. Another thing we might do is there's lots of these sort of flow charts out there on the internet about how to pick charts, but you kind of have to understand, like, am I doing a relationship? Is it a comparison, a distribution? These words are kind of vague, they're sort of coarse, and they still leave you with a dozen of different options to try, all of which can be pretty generic. And there's no way you could use a chart picker or an example gallery to come up with some of these kinds of graphics. Like if you just sort of open an edition of science or nature, or if you look at some of these great data artifacts, or I'm also noticing algorithm visualizations are getting very popular these days now that we can make them more easily. Like, how do we know that these designs are good, useful, effective? Once we get something out, how do we iterate on those designs? And even if we're talking about very simple charts, like a grouped bar chart, just picking the chart isn't enough, right? So I'm going to show you three versions of a grouped bar chart representing the same data set. And that data set is just going to be the heights of two children, Charlie and River, at 3 different ages. And I'm going to flash the chart on screen for like 5 seconds, and I just want you to tell me what the first thing is you see in that group bar chart, okay? All right, here's the first one. Sorry for the labels being a little messy. Does anyone want to tell me what was the first thing they noticed about the data set?
Charlie's bigger than River.
Okay, great. Charlie's bigger than River, right? How many people was that like the first thing that they saw, right? Okay, maybe like half the room or so, right? Okay, so here let me show you another chart, another version of that data set, and I'll show you it for 5 seconds. Okay? All right, so what does anyone want to, do we see anything different this time? Maybe, yeah?
Did River actually shrink?
Yes, River shrank between 10 and 12, right? And so this is the same data set. It's the same chart type. They're both group bar charts. But the first thing you see about it is different, right? And we can actually play this game a different way. And instead of changing the visual, the spatial structure, I can change the color. And maybe now, like, it is a little bit easier to see the trend in River's height decreasing because this color is changing our association. And so actually, the thing I just showed you is based on this research by Boger and Franconieri from a couple years ago, where they did a more widespread study, and they found that, and basically they showed people these charts for 15 seconds, and they asked them, like, did you see anything interesting about this data set? And when we group it by age and then by person and then by age, only 13% of people miss this kind of shrinking trend. But when you group it by age and then by person, about half of people are missing this kind of like weird trend in the data set. So these are all the same kind of chart, and their takeaways differ. And so the key idea of this talk is really that when we're designing a graphic, we're doing a lot more than just picking a chart type. What we're actually doing is we're creating a visual structure that our readers are navigating. And the way that we arrange shapes and the way that we choose colors and labels and things like that are really having a very strong effect on like what either we as someone exploring a data set or people we're trying to communicate a data set to are getting out of that. So over the course of this talk, I'm going to show you sort of many examples of how you can kind of like evolve a visual structure given the same data set, and how that visual structure is going to change what we're reading through that data set. And the other thing I want to kind of impress upon you is how thinking in this structural way kind of frees you a little bit from this rigid lens of chart types, and also some of these black and white design rules like pie charts are always bad or dual axis charts should never be used or things like that. And to think a little bit more precisely about your visualization design. Right, so the other sort of organizing principle I would like you to think about is there's some mapping between the data structure we have going in, the visual structure we're constructing, and then like what the reader's taking from that structure. But to talk about visual structure in a precise way, it's useful to have a language for talking about that structure. And that's basically what I've been spending my PhD doing, is creating a formal language that's also, basically like a JavaScript and Python library for constructing graphics. We have a couple papers about it. It's MIT licensed, open source. I'll give you links at the end. And it's mostly in TypeScript with sort of Python bindings that are reflecting the TypeScript. And I was hoping to have the Python bindings totally up to parity with TypeScript, but then I got sick last week. So it's going to take me a little bit longer, but it's basically the next thing we're doing. So how do we even think about making a language of visual structure, right? So typically what we do when we're making these kinds of formal languages is look for good primitives that can serve as like this basis of a language that we can compose. And luckily in visualization, there's a lot of literature in Gestalt psychology around how people organize visual structure. And these are 5 of the big ones. We saw similar attribute and spatial proximity in the grouped bar chart example. But there are others that are also really important too, like containment and connection. And in fact, I've ordered these roughly in the priority of how significant they are. So for example, in the containment and connection ones here, all the dots are evenly spaced, but it's the fact that you draw a line between them or you draw a box around them that's taking precedent over these other readings in the chart or in the graphic. And we can look at some of these more complicated sort of like chart diagram hybrids and see these Gestalt relations are all over this, right? So the labels are using connection to draw arrows to different regions. We see similar colors relating parts of the scatter plot to the diagrams in the middle. And those properties are taking precedence over the fact that we have this vertical column in the middle of the graphic. And so really those principles are all over these kinds of graphics. But that's enough of my academic-y theory stuff. I want to get a little bit more into how GoFish as a language works and how we can start thinking about visual structure. So here's a basic specification in GoFish for a bar chart, right? It has 3 pieces. It has this chart call. If you've used Altair, it's a little bit like Altair, or like Seaborn Objects is probably the closest analogs, but it does some things pretty differently. The first thing we do is we have this chart sort of object, which we pass a data set. In this case, the data set has 3 fields. It has a lake column, a species column, and then a count of the number of fish of that species caught in each lake. We then have this flow method, and we call things in the flow method graphical operators, and these are basically ways that we arrange a visual structure. So here we're using the spread operator, which is a little bit like a facet, although as you don't usually facet rectangles, but here we're basically doing that. And so spread lets you kind of create one region per key in the lake, and then spread them sort of horizontally. And then finally, we have this mark thing, and here we're rendering a rectangle where the height of that rectangle corresponds to the count, which is sum over all the species in the lake in this case. And even with this simple chart, we can see some of the things that this bar chart is affording, right? It's very easy to tell, Lake F had the smallest number of fish caught, and Lake B has the most number of fish caught. And it's easy to see these pairwise comparisons, right? And so the claim I'm making is that those queries aren't necessarily a property of the bar chart, but are coming from the fact that we're like base aligning and horizontally spreading a bunch of things, right? And so it's a property of the spread operator rather than of the bar chart itself. So another kind of spatial relationship we have are part to whole relationships. And so for example, we might want to look at what's the breakdown by species of the count in each lake. And so to do that in GoFish, we have the stack operator. And so we can just actually insert the stack operator under the spread operator in the flow, and then add a fill channel for species. And I want you to note that the operators in this flow thing can be chained, and so you can create these hierarchical structures very easily.
Why is the legend upside down from that?
That's a good question. The reason it's happening here is because the coordinate system is going bottom up there, but actually the labeling is going top down. Yeah. Yeah, we haven't quite touched the legends in a while, so that's a good question. Yes, it's good use of Gestalt grouping principles. Okay. Yeah, so this is giving us some other affordances, right? Now we can make these kind of part-to-whole comparisons where we can ask, like, okay, about what percent, what fraction of Lake A is, bass, or, it also allows us to do these pairwise comparisons of species across lakes. So, okay, salmon is kind of low in Lake A, but then, as we get towards Lake D, E, F, it's, we caught a lot more of them in those lakes. And another way I think that's useful to think about it is just to have this little mnemonic of like, okay, the outer key that we're kind of grouping by is lake, and then we have another key where we're grouping by species, and there's some part-to-whole connection. But there's a lot of different ways we could organize these nested keys, right? So one thing I could do is instead of doing a spread and a stack, I could do a spread and then another spread, which is basically what we saw with the group bar chart, right? Or I could spread by species and basically group by species and then group by lake, and now we have exactly the sort of grouped bar chart thing we had earlier. But here we're sort of thinking about it in terms of like, what are the sort of graphical operators, the visual structure, and the order in which we're doing those, right? Yeah.
I have a very sort of first principles question.
Yes.
So it feels like, like in my brain, I'm comparing this to how can I make this in pandas, or if you're old like me, how you can make this in GNU plot and how fun that is.
Yeah.
But I feel like the value adds here, if I'm understanding it correctly, are number one, you have this. I guess you're bringing in sort of the theory of visualizations, like what makes visualizations effective. That's one piece of it, and then the other piece is sort of the data, like the plotting and the query piece are sort of the same in some way. Am I understanding the value prop correctly?
I think I'm understanding. Could you explain, when you're saying the query piece, are you talking about the data transformation or the visual reader querying a visualization?
I feel like I mean, like the way you're plotting the graph, right?
Yeah.
Like it looks like it understands the data as opposed to like manually trying to plot something in pandas. You know what I'm trying to say? Like it's a first-class citizen.
Yeah, the data.
Yes.
Yeah. I
guess maybe instead of me articulating the full value proposition over like just doing this in pandas or matplotlib,
right.
Could you articulate that? That would be really helpful.
Yeah, sure. Yeah, that's a great question. I'd say like the value prop over something like matplotlib, right, is like, even if you try to do a grouped bar chart in matplotlib or something, you end up going like really quickly going down to like, let me compute the width of that everything's supposed to be and then compute an offset and like do all this manual calculation. And honestly, like especially LM generation, like is that so bad to write? Like it's not really that bad to write. But I think the value prop is coming from like, oh, actually, if you do abstract that stuff away into like, I'm doing a spread, now I can start to think in this way about like what is structurally going on and less like, okay, this thing is width equals 20 plus like offset, offset times blah, 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 blah. So, pre-AI, where a lot of this work happened, it was like, oh, it's really elegant. It's really nice to make. I think like the way I'm really thinking about it now, or starting to think about it, is like it gives you a very declarative way of thinking through how these charts are structured. And then it makes it really easy to just, you can keep adding spreads here, right? So you can do cool stuff. I don't have an example here, but there's one online of like, you can do a waffle chart by just like, making rows of rectangles and then, spreading those vertically and then like stacking them, and then like take a bunch of the rectangles and spread those horizontally, and then you could make like a faceted, waffle chart if you really wanted to or something. And I feel like those moves are actually like very natural in GoFish compared to something like Matplotlib. I don't know if that was fully.
Yes, that's what I was trying to get at.
Yeah.
Thank you.
Yeah, great. Okay, yeah, so these are, just to sort of recap, like here are 3 different ways of kind of nesting one key and then another key. Another natural thing, obviously, you'd want to do, or not obviously, is like, a heat map is another version of this, right, where we're basically doing this kind of like Cartesian product or something, right? We don't have this nesting affordance of the stacked bar chart, but instead, like, it's actually easy to visually scan horizontally and vertically, whereas scanning horizontally in the stacked bar chart is like more tedious, I guess you could say. I think, at least for me, the trend in salmon, for example, jumps out a lot more immediately in the heat map than it does in this in the stacked bar chart. Okay, so here's yet another way that you can kind of change the afforded messages of a chart, which is just to sort things, right? So again, another advantage of this hierarchy thing is we can very easily talk about like, okay, I want to sort inside of each stacked bar, and you can do that sort of separately from sorting the lakes themselves, right? But you can see here, oh yeah, also the color shifted again because of like, we got to get back to legends, but basically like you can see in the one on the right that salmon is going from like the least populous in lake A and B to the most populous in lake C through F. Whereas on the left where salmon is green, it's a little bit harder to tell the relative ordering of everything, right? And so in GoFish, it's very easy to do this move compared to something like a lot of the sort of high-level charting libraries, because we basically think of this flow as this thing that's taking data and like both like grouping it and then also doing layout. Is we can just do like the grouping thing or just do the data transform thing. So here we use derive to take in the data set coming into each lake and then sort all the values that have been grouped there, so that we can arrange them so that species are the count is on top. Okay. Right. And so here I want to say like the sort of like visual query that we're affording now is the greatest or least species total within each of the lakes. Yeah.
So the order of operations you do is spread, derive, and stack.
Yeah.
Does it always have to be done like that? Can you stack before you spread or derive? That's a very good question. So stack is weird. So in theory, yes, you can do that. If you do a stack before the spread, Maybe stack before derive.
Yeah, you could do that, but then derive would be getting a single row basically, and it wouldn't do anything. So the order does matter here. Yeah, the order is important, and that's convenient because, like I was showing in a couple slides previously, like the order in which you spread things or do spread and stack has a big influence on that structure. Yeah. Good question. Thanks. Okay, here's another one. So here we're seeing sorry, I'm looking at
Slides in the back. They're the same slides. Okay. Another thing we can do, right, is add in some more Gestalt groupings, right? So here I've added in connection as a grouping. And if you remember back to my slide about the Gestalt grouping principles, you might remember that connection is actually one of the more salient of the grouping principles. And you can actually see, like, we haven't run a study like this, but I would imagine you would find that the first thing you notice about this could be, oh, that the salmon, starts low and then moves high and then sort of, keeps growing or something. Or like, trout was the most populous in the first one and then sort of descends every single time. I think this is another interesting one where we don't just have like one set of visual structure, which is this kind of stacked bar chart thing, but we also have this overlapping structure that's, so like an individual shape is taking part in two different structures at once.
And it look different depending on what order the lakes are.
Yes.
So can you reorder them, or what's it?
Reorder the lakes?
Yeah.
Yeah. If you put a derive, actually to go back to the previous question, if you put a derive above the spread, then you could like reorder the lakes, for example. And like, I also definitely want to point out, like, this chart is not like categorically better than the one on the left. There's all these interesting,
This feels like it's almost making up false trends in some way. Like if we want to make up a story, we order lakes in a certain way.
Yeah, I think, so I think it depends on, I'll touch on this a little bit more later. I think it's tricky, right? Like, I think this is the problem, is like, small changes to the structure can lead to like these interesting questions of like, what are you going to take away from this graph? I think like, part of me is like, we need to do a lot more research or understand people's tacit understanding of like how these charts work, because I think it's actually like a very important question. I think the other part from the design perspective is like, if we understand those phenomena a lot better, we can use it to our advantage, not adversarially, to like, design graphics that are like both like visually compelling, but also like conveying the kind of thing we really want to convey. It's tricky, it's weird, yeah, but that's what I think is so interesting, is like, there's actually this very large space of graphics, and they have all these, what is their potential for meaning? But hold on to that thought, because I'll get back to it a little bit, yeah. I want to talk a little bit about how we build that ribbon chart in GoFish. So again, like, you could use the ribbon chart function if you want, or we can think about it structurally. So the first thing I'm going to do is adjust the spacing of the spread to give some more space for the ribbons. And now what I'm going to do is add a second layer that refers to the marks in the first layer, so that I can connect them. So I'll use this this layer function so I can add another layer. I'll name this mark, which is actually going to basically give me a new data set that's like the old seafood data set, but enriched with references to all the shapes that I've made. And now I'll make this second chart layer to make this. So let me go through what all the arguments are. So the first one is, I think, a really cool part of GoFish, which is the select thing. So what select allows you to do is basically select some marks that you've drawn previously and get the data and a reference to the mark like associated with that data. And this turns out to be a really, really powerful primitive, because you can use it for all kinds of things, like drawing a label relative to a mark you want to label, drawing ribbons in this case. We're also thinking about how to use it as a way to add interactivity, where you basically like want to draw a region or select a thing that depends on a mark that already exists in your graphic. And so I think this part is really cool. The next thing we're going to do is group that selection by species, because we want to basically make one ribbon per species. And now we're going to use an area mark, But unlike a normal area mark, which is just kind of like a function that spits out an area chart, the GoFish area mark takes in references to these existing marks and will draw these ribbons to connect those marks that you've given it. And so that's basically like the whole specification for drawing this ribbon thing. And again, I want to kind of impress that like the specification is mirroring the visual structure in some way, where you're getting like, this kind of like relationship between existing marks and the things that are drawn is like present in the data in a way where you would probably have to sort of drop down and draw Bezier curves yourself if you really wanted to get this kind of functionality. So now, partly to the question of like, what is it even saying, right? Another knob we have to turn for how we can kind of change what we're reading off of this is color, right? And this is something where, when I look through like example galleries for a lot of the charting libraries, I don't see a lot, but when I look through like the New York Times or other kinds of news data sets and maybe some of the visualizations coming out of the AI labs right now, like it is a very prominent property is the use of color to really highlight the one or two things that they want you to take away from the graphic, right? So on the left, there's a bunch of things we could say, and to me it feels almost like unfocused, like I'm honestly not really sure what to attend to, and like people were mentioning earlier, like it's possible that reorderings of the lakes or reorderings within the bars is going to change a lot what we see first or how we interpret it. The one on the right is a lot more focused, right? So maybe what we want to say is, okay, salmon increased and became the most populous, and trout decreased from the most populous to nearly the least populous, right? GoFish makes this really easy to do with this discrete palette function. And I think that the thing that we do that a lot of other libraries I've seen haven't really done is just give you a default gray when you don't specify stuff. It makes it really convenient to make these sorts of charts. It just kind of we just kind of did it, and we have this big data set internally of like New York Times graphics we think are cool, and we're like, look at all the coloring patterns they used. Oh, we can just do this, and it like gets you 80+% of the way towards the kinds of techniques that people are using in these really cool, newsworthy graphics. But yeah, I want to point out like color is a really precise way to sort of promote or demote queries that a user might be making about a visualization as they're reading it. And I sort of mentioned kind of some of these. Right. Oh, yeah.
Kind of jumps out at me. Why that element that the salmon that goes from second to the third? It's so thin. It looks like, is it just an artifact, or are we trying to say something there?
It's just an artifact. So the curve is basically just like a Bezier.
So it just happened.
It's just because the bars. So there's another way where I like made the bar spacing wider, then I think the ribbon would become thicker because like as you move them closer and closer together, it's just going to become like a straight line with no area. Yeah. The intention of that ribbon is not to convey a quantity necessarily, but more like the connection between neighboring bars. But yeah, it's definitely like, these are all great observations, honestly. Yeah.
Depending upon if you change around the order of the lakes, we can make a similar story about pretty much any fish, right? Like if we just start with the smaller, like how we do it.
That's true. I missed a part of my introduction of this data set, which is that like the lakes are connected by some river. Like there's some, so that is an important point, which like suppose there is some connection.
Okay.
I think that's actually a really important point, which is one of the things that the kind of ribbon connection is suggesting is about the data schema, which is that like there's some contiguity, there's some ordering or contiguity on the lake keys, which is actually not something that's afforded by just the bar chart itself. Yeah, that's it's a very important point. Yeah.
But of course, the lakes wouldn't necessarily be linear. as in this data set presumably, but they could be connected in some strange way.
They could, yeah.
Couldn't do so easily with a linear arrangement.
Right, yeah. I mean, so you could imagine like instead of doing an outer spread, you do a scatter. You know, if you have information about where the lakes are, right, you could position them some differently in space. Yeah. I saw a hand over. Yeah,
So I have a stalled question.
sure.
I think graphs can enable you to sort of display an answer to a question that you're asking. Is lake A and B connected? But they can also ask, sort of help you find relationships. So which way are you heading towards? Do you have a specific question that this tool would enable displaying, or will it actually help you find relationships?
That's a good question. Let me restate it and see if this is what the question was or if it was something different. So I think like traditionally in visualization research, at least, there's a distinction between like exploratory data analysis where you don't really know what you're looking to find. You're just trying to explore a data set, and then like explanatory data visualization where you know the takeaway message you're trying to convey and you're trying to communicate that, like let's say in like an article or something. Is your question like which one is GoFish for?
Exactly. Is this
Yeah.
a New York Times question or
Yeah.
is it more exploratory?
Yeah. That's a good question. I think the use, it's a little bit both, but having this conversation, I feel like a lot of these issues lean more towards the explanatory side where like you're going to use these like weirder graphics maybe when you have a very particular point. And so the only queries per se you want people to do are like very small and can be controlled in this way where you avoid some of these like spurious readings potentially. A lot of the cases I'm really interested in are like, I have this weird data set. I don't know quite how to visualize it because it has this weird like key structure or like it has way too many, there's way too many taxa and I need some way of organizing that and I want to combine like, sometimes I think the data schema itself provides a strong forcing function for like what the chart should look like, which is like, okay, I have this tree structured thing and then I need to like, I have some distributions at every node in the tree structure. So let me like throw some pie charts at the tree structure. And I feel like GoFish is very good at that kind of thing because it lets you compose visual structure very easily. And also lets you do this stuff. But it's not really trying to be like, I have a random data set, let me automatically generate something that will look good. I don't know if that's really...
When you first do it exploratory, then I would want, say, lake A related to lake B, maybe put those together, try to find those relationships. Here, if I knew exactly what I'm doing, then this is just making a pretty picture. Right?
Yeah.
It's not necessarily letting me explore.
Yeah.
But but if I knew what I wanted, it'd make it precisely what I want.
Yeah.
Which is great.
Yeah. Yeah. Yeah.
Just trying to distinguish.
Yeah, no, that's a good question. I guess the way to phrase it for me, like in my head is like, I'm not as interested in the like, let me figure out what to do exploratory in the next like 10 to 30 seconds, but like the kind of chart you're spending like hours to days to weeks on, and you're trying to really refine the message for like, this figure is going to publication, this figure is central to like, some debug information I need to get out of the system that I'm going to be looking at every day. Like that's kind of the kind of graphics I'm thinking about most. Yeah. Yeah.
Have you thought of like making the charts that are good for AI? So you basically you can maybe like even experiment to like create exhaustively different arrangements like in Snapchat, feed it to AI models and see what they pick up like. And maybe like what's the best way to communicate information to the AI model versus people? Like how?
I see. You mean like what's the best kind of chart to communicate to an AI?
Yeah, or like one AI model wants to communicate to another, like what charts, like what kind of charts would they use?
Yeah.
Because lots of multi-model ones, they do like pick up a lot from visual language. Like there's lots of visual models, like, and what's the best representation?
Yeah, that's a good question. I guess I'd want to compare to like a text-based line. I've started to experiment with like Viz plus AI more aggressively. I would say only the past like month or two. Yeah, I think it would be interesting to think about. Yeah, and I feel like I'm always crossing my fingers for the vision models to get like a lot better. I feel like they're not quite where I would like them to be. But
But you
yeah.
can build the framework and you can just fine-tune what the techniques are best for like the
Yeah.
generation of models.
Yeah, that's true. Yeah. Yes.
Another way to think about it related to the two previous questions. Did you think about a quantitative way to compare usefulness or informativeness of different ways to visualize the same data, and eventually to have, let's say, some kind of score functions, like some scalar that you can optimize against, and then you can design an algorithm. Give me the most informative visual for this kind of dimensionality of the data. What's the entropy? And I want to get maximum entropy to maximum highlight the difference in the data.
Yeah, it's so like quantitatively assessing the utility of a given chart, yeah. I think it's a very interesting question. It's a very natural question to ask after this. I think the research community has probably like shied away from doing this recently, some people, because there was an old theory called the like visualization effectiveness theory that was basically like the way to measure how accurate a chart is how accurate or how effective a chart is how accurately you can read data off the chart, which is an okay test, but actually like is like not sufficient. And so there's a bunch of research that's like, oh, like this isn't good, so like we shouldn't study like utility of charts anymore. I think we could maybe get a little bit more towards like quantifying it to some extent. There's some really weird like non-linear behavior when you like have color and shape and size and rotation like interact in like really weird like complex ways. And there's also like individual variation. But I bet you could like make a data, crowdsource some data about like different readings of charts and then come up with some kind of predictive model for like what chart is best given like this set of queries, for example, you would want to support, like the set of visual queries. Yeah, but I think it's like, yeah, I feel like it's a very exciting natural thing to do that I wouldn't be surprised if we end up doing the next year or two. Yeah. Okay. So in the spirit of like possibly not very effective charts, here's another version of it that's possibly even less effective, but it's cool. It's cool. Okay, it's cool. And what I want to impress upon is like, depending on what the takeaway message is, and maybe, probably don't use it in a purely exploratory context, right? Like this may be an okay chart, right? Maybe the only thing you want to convey is that, trout started popular and then got unpopular, and salmon was like less common and then got more common as you go through the lakes or something. This would work okay for that. I don't know that it's the best thing, but I think this to the other question is like, if we look at it purely from an accuracy or readability standpoint, it's probably not the best chart. If we look at it from some other ways of like what might gain, have visual interest given the takeaway messages I want to have, like this chart might actually fare a lot better. And to the accuracy point, I want to talk about pie charts. So this is basically a reinterpolation of a graphic that was in that paper about accuracies and effectiveness ranking. That's basically like, okay, pie charts are less effective than bar charts for a lot of tasks, and so we probably shouldn't use them, right? Like pie charts for fine-grained comparison is like complete trash, honestly. Like on the right, you can clearly tell the ordering of the heights in these bars. But on the left, like it's really, really hard to tell But I could just as easily construct a different data set. And in this one, I could ask you, okay, like about what portion of the total is the purple, is group C, right? And in the bar chart, I really have to do a lot of work to figure that out. Even if it were a stacked bar, I would really have to work. I wouldn't be able to tell very precisely, right? In the pie chart, I can basically see okay, blue is about a half, and yellow is about a third, and purple is about a fifth, or something like that, right? So the story is a lot more complicated than just how accurately can I read things from the data. It's sort of what level of accuracy do I need? How efficiently can I read something up to that level of accuracy? And we can sort of use those kinds of inferences to start to talk about slightly more complicated graphics. So here, I can do a scatter operator. I see this a lot in marine biology papers where they're going around and they're sampling, imagine these are all the lakes and you've sampled, species in different lakes, right? And this was really funny because I was talking to my advisor one day because I was looking for interesting charts to use, and I was like, oh, I found this cool chart. It's called a scatter pie. And he was like, why would anyone ever use that? And then a couple weeks later, we went down to Hui, and we talked to some marine biologists about visualization, and we're like, what visualization problems do you have? And someone I just remember it was on the whiteboard next to me, they started drawing a scatter pie, and I was like, what? And then they're walking me through how do you use it, right? And I think it's for that reason I was explaining before, which is you can just tell at a glance okay, this green, the salmon are really very popular on this right-hand side of this chart, right? On the let's say the eastern side of this map, right? And if I replace that with tiny little bar charts, you wouldn't really be able to tell as easily that they're about half or whatever, right? And I think the GoFish kind of visual structure thing lets you kind of make this sort of inference where you're okay, I sort of know what the scatter is going to do, and I sort of know what a pie is going to do, so I think I'm going to know what a scatter pie is going to do. And this is where I think it would be interesting to study is that actually true? Is there a composable way that we can think about the utility of both and combine those? But it lets us do some other interesting things because it's well, if all we care about is just the vibe of roughly which thing is larger in one place and not in the other place, well, we could just do stuff replace the pie with petals, right? And there's some very famous award-winning infographics that basically use this style, right? And arguably, it actually makes some of the trends pop out more because this glyph symbolic thing at the top is very sort of green heavy and all the other parts are very small, right? Whereas the one to the right of it seems more balanced, right? And you probably want to study a little bit more what inferences are people taking away? Are they what you expect to see? But especially as you're getting more to that explanatory context, you have some of this liberty. Another thing we could do is have this kind of a balloon glyph where now we're just saying, okay, I don't even care about the fraction. I just want to say, okay, the biggest fish is going to be the body of the balloon. And then the second most common is going to be this little highlight. And then the third is going to be the knot at the bottom of the balloon. And so we're getting a little bit more towards a Chernoff face or something. But again, that actually makes some of the properties stick out even more, right? And also it's kind of fun. And you never get that from a chart menu, right? But you could maybe find your way there by thinking kind of structurally or through what people are reading to end up in this place. Yeah, so what I want to say is when we think with structure instead of chart types, we can compose structures to come up with new designs while still reasoning kind of precisely about what they're communicating. And so I'm just going to shift a little bit more conclusion-y. So if there are any questions about some of that stuff before I shift, this would be a good time to ask.
We have a few more minutes, though, if you want to save the questions.
Oh, sure. Okay. Yeah, sure.
Who uses a balloon chart?
Could be you. You know, I think like I also just have a personal mission of like, I feel like the world should have a little more whimsy in it. And I think actually AI makes this like way easier. You know, is it gonna end up in a scientific journal? Like probably not. Is it gonna end up on like, I mean, it could, I don't know.
Well, where's the whimsy bit?
Well, I won't, I'm not saying you shouldn't do it. You know, I think like, does it end up on your personal blog, on LinkedIn, in your talk, you know, and like, you know, your fun lab social where you're trying to convey your research to someone else. Like, I think there are a lot of different areas where you can like, think about like different ways of creating the same kind of, the same sort of message. Yeah.
Are the balloons and flowers, they part of the library? Or is it just hypothetical?
I hid the code because it's a little gross currently, but it does work. It is in the library. And the way this is happening is like balloon is a custom glyph. That's actually a layer of a bunch of shapes, which I didn't really talk about here, but basically you can put like anything in the mark. You can put a chart there, you can put a layer of stuff there, you can put a shape there, and so you can like compose these things like really very nicely. Maybe I'll get through the conclusion unless it's a burning thing, and then we'll get back to the questions. Yeah, okay. What just happened? Okay, so we took this one kind of data set, I sort of like threw in some positional stuff at the end and did a bunch of these deliberate structural moves. And each of those moves was changing what was easy and what was hard to see. And I think we all had some great questions around like, well, what actually are the takeaways? And I think we're still trying to kind of figure that out as a research community too. The interesting part, right, is like we weren't really thinking of a menu of charts necessarily, even though like charts are a great shorthand for common structures, right? We're really thinking in terms of like visual structure and what those visuals were affording. And right, so those charts were sort of visual motifs. There's kind of a table I won't dwell too long on about like operators correspond to some kind of data type key and have some kind of gestalt, grouping principles associated with them. And I think like we're interested in making this kind of correspondence a lot stronger, more precise in the future. But I basically have like 3 takeaways that I'll leave you with. Chart types are great shortcuts, but graphics are actually, can also be thought of as these sophisticated visual structures. Changing that visual structure changes what your reader can or can't see in probably predictable ways, although we don't totally understand that yet. And thinking structurally helps us move beyond familiar charts and rigid rules to designs that might better fit our data or task. Okay, here's my like plug for all my stuff and some whimsy. So Python is basically almost there. I'm also starting a newsletter where you can get updates on like the GoFish features that are being added and when the Python release will be ready. And I'm thinking about writing a book about all the visual structure stuff to help people with design. So I'll also be sending out some early sneak peek stuff about that on the Button Down newsletter. So thank you.
We probably have time for one question, especially from somebody who wants this thrown at them.
Whoa, we got a very enthusiastic hand in the over there.
Right?
This is very cool. I really like the thing about the sort of structural thinking of the graphs and also the idea of the TypeScript for this. Thinking about a lot of my friends who are academic historians really want visualizations that are custom and read things like the New York Times and see the visualizations and want them in their history, but don't necessarily have the technical skills to produce it with like matplotlib or something. So they come to me and I make it for them, but that's a horrible system. And I'm wondering, especially with the TypeScript and the sort of building up of structure that you had, like I was really impressed how easily it made a polar plot. If there's like hey, paste your CSV in and then I'll ask you a series of questions and we'll sort of agglomerate these structural elements as like just a website. And then they get their plot out and then it's like reproducible for them, easier for them, and we learn more history through these incredible visualizations. Is that possible?
That's really interesting. I mean, I hadn't thought about it. I'd love to chat about that more. It seems pretty cool. I mean, it reminds me of stuff like Flourish or Data Wrapper, but maybe based around structure instead of chart types. So that sounds cool. Yeah. Great.
Yeah, so